Good afternoon, good evening, good morning, good night, everyone. I know you're joining from the different parts of the world, and thank you. I really appreciate your interest to our Ovogene online webinars, and thank you for the registrations and connections. This is one of our webinar series, and today it's dedicated to the artificial intelligence in IVF. We have an invited speaker and whom we are really happy to welcome. And thank you, Juan, for joining us. I will present yourself. So Juan Fraire-Zamora received biology degree in Mexico and his PhD in the University in California. He worked as a researcher in different top research centers in the world. And currently he is a researcher in the data team at Eugin Group and an active member at ESHRE. And he's going to present regarding machine learning in the IVF clinic. And my dear colleague, laboratory director, scientific advisor, senior practicing embryologist, ESHRE ISRM certified embryologist who worked in over 15 countries, expert in oocyte vitrification and the mitochondrial transfer techniques, Birol Aydin, is going to talk about artificial intelligence for the oocyte selection. As you know, Ovogene is an expert in the egg donation field, and we've been involved with the oocyte donation for over 15 years. And we are always looking forward to implementing everything new and effective, what will work for our patients, for our team, for our partner clinics globally. And we believe that the best technologies of the artificial intelligence, which we already implemented in our daily routine activities, are really important and are really helpful. So we will share that best experience with you. That webinar is dedicated both for the individual patients who are going to be treated with the IVF and as well for the professionals in the healthcare, in IVF, clinical and the embryological practitioners. So how we reduced our workflows, how the IE brings the efficiency and predictability for the successful IVF treatments. I'm really looking forward for our next hour time together and for both presentations. We are going to run Q&A session in the end of the seminar. So you are welcome to write all your questions, anything you want to discuss, any of your thoughts of your practical experience, which you would like to share with us, or ask any questions. So we will be happy to answer all of those in the end of both lectures. You can write them down in the online chat, which you can see, it's already open. So we'll be happy to communicate with you. And happy to continue. So, Birol, you will start to present, and then we will continue with the Juan. Thank you so much.
Okay. Hello, everyone. So today I will try to talk basically for the oocyte selection by artificial intelligence, but not just oocyte selection. Of course, we are an egg bank, and for us, priority to select the best oocytes and to give possibility of the best outcome for the patients and the partner clinics. But still, artificial intelligence is a fully algorithm for the sperm selection, for embryo selection, for laboratory control and quality management process. So I will try to talk about all this process by the artificial intelligence. So as you know, the machine learning actually allows all computers systems to detect the different patterns from the different complex softwares. While all clinics are using in a site medical softwares, they are keeping data of the patient, their previous IVF histories, how many eggs they get, how many fertilization they got, how many blastocysts they got. So from another side, from the doctor side, there are stimulation protocols, there are body mass index, different hormonal results, all they are keeping in a one medical profile. from another side, while we are trying to implement machine learning and artificial intelligence, which is the controlling all morphological selection for the oocyte and embryo, of course, still we should consider the other data as we are getting clinical data from the patient. So the machine learning is just matching both data together and trying to create the best efficiency for the patient. As an algorithm, artificial intelligence, as I said, from the different base of the server or software, just collecting data. From one side, they are collecting data from the regular medical softwares as identifical information and clinical information of the patient. From another side, in the IVF laboratories and embryology laboratories for the quality of the oocytes, embryo, the fertilization rate, maturity rate, the blastocyst rate, euploid blastocyst rate. So all this data just completing and controlling by the artificial intelligence. As an algorithm, artificial intelligence is starting from the identification part, then the clinical part, after that andrology laboratory for the sperm selection, then IVF laboratory for oocyte and embryo selection, and finally system is giving us the chance to get prediction of the outcome. As oocyte selection, of course, we are focused on the several morphological criteria, as we are calling the cumulus complex morphology, which is covering to protecting the oocyte, while oocyte is getting from the follicle as a protected part of the cumulus complex. The morphology of the cumulus complex, the zona pellucida, which is the wall of the oocyte, which is protecting the cytoplasmic components as a safe. The perivitellin space, which we are calling between cytoplasm and zona pellucida, this empty part, which is important for us, this diameter of this part. I will explain for the further slide. The polar body appearance, which is keeping the genetic information as a first polar body and second polar body. The shape of the oocyte, the meiotic spindle, actually very crucial and important, which is keeping all the genetic material information, DNA information. Granulated cytoplasm, as a cytoplasmic activity is very important, and cytoplasmic maturation is very important for us for the better outcome for the further process. And of course, we can keep time-lapse activity of the oocyte, how oocyte getting during vitrification process, how we are vitrify them, and that give us chance to follow up in the further case if we have some kind of issue regarding the quality of the towing, survival rate, so we can back the time-lapse activity and we can watch this record and find out the problem. As cumulus complex morphology, there are different theories, but most of them, of course, are saying the cumulus complex morphology is not connected directly with the fertilization rate, cleavage rate, and clinical pregnancy rate. However, it's still important because regarding the cumulus complex morphology, that we can determine the further process, as we are calling denudation, which we are cleaning cumulus complex cells. So we can understand if those oocyte has risk for the damage by micromanipulation. So from that perspective, of course, it's important to determine it. As I say, the perivitellin space, which we are more focused on while we are using the cryoprotectant, and the percentage of the cryoprotectant which will be absorbed by the oocyte. So when perivitellin space is large, so this amount of the cryoprotectant can be harmful during the towing process. From another side, absent of the perivitellin space also risky because there will not be enough the area which will keep the ice crystal or cryoprotectant percentage. So because of the osmotic pressure risk, so oocyte will get, of course, not survive after the towing. So the morphology of the first polar body, as we are trying to freeze oocyte, and many theories find direct connection between the fertilization and embryo quality rate and polar body morphology, we are trying to choose the compact and single polar body without fragmentation and without any kind of degeneration. and the appearance of the O plasmin oocyte, of course, under regular microscope, still is so difficult to detect cytoplasmic maturation or the polar or regular granulation. Uh, the severe granulation, which we are able to detect under the regular stereo microscope, but still we are limited. The artificial intelligence can use additional liquid crystal analyzer optic, which can detect also amount of cytoplasmic maturation or the granulation level. As zona pellucida, this is a very critical actually, and we are more focused on because between zona pellucida thickness, as we are calling thickness, but we are determining that as a fringes, it's very important for the implantation rate and also for the blastocyst outcome. Why it is important? While under regular microscope again and stereo microscope to measure birefringes, it's not possible. While we need to use some polarizer to analyze this. When we use the polarizer and we find out the different zona birefringes level, the different oocytes, we find out when we receive embryos from those oocytes, always which we have high zona birefringes, always giving higher pregnancy and implantation rate. And this is very critical for egg banking, so we can avoid which oocyte has low zona birefringes. As you know that when we select the oocytes, so we have to be so much focused on regarding the quality. The left side, there are three very sweet cats. Of course, we cannot say which one is much sweet than another. All of them are so beautiful, but the oocyte is not the same. Small details can change the outcome. Small details can give us the better result and better outcome. So as artificial intelligence algorithm we are using, from one side is coming morphological specification, from another side artificial intelligence collecting data from different based of the softwares or server, different clinical information. I already said what kind of morphological specification we are focused on, and artificial intelligence actually to keeping all this morphological specification with the mathematical algorithm. But from another side, the donor clinical information are coming and collecting different server as age and body mass index, the previous cycle of efficiency, stimulation protocol, height and weight. So those all information also collecting by artificial intelligence. So that means if I select the oocyte perfectly from one donor, that is not enough for artificial intelligence, because if artificial intelligence detects those donors have a previous efficiency with the low outcome, so system will alert me, okay, that you select this donor for the egg banking, but this donor had very low outcome on the previous cycle. So this is the part of artificial intelligence which always alert us for the risk situation. Artificial intelligence, the focus on mostly for the segmentation. So we are giving the system to detect of the segmented area and to focus on and to make all measurement and classification for this segmented area. So the first, all extraction from this segmented area is coming, and it's getting a 3D image, and then the classification between different segments. So basically the advantage of new brand of artificial intelligence, it's not just connected with the time-lapse incubator or embryoscope. So it gives us chance, or to many embryologists, even to use that directly with their invert microscope with high quality HDMI cameras, which give the more possibility for them to use in the common practice. As artificial intelligence, as I said, it's mostly the focus on the segmented images. So it's catching the part of images to just detect and crop and just analyze the part by part, which component we want to select and analyze by the artificial intelligence. And we are giving to system different reference values, for example, for size of polar body, for size of spindle, location of spindle, diameter of oocytes. So from all this segmented area, the mathematical calculation is coming. There are, of course, many studies which are working for the artificial intelligence for oocyte, for embryo, and for sperm. So all of them basically focus on those segmented images. And there is kind of algorithm on the deep learning, and those algorithm is making the mathematical calculation. So after those mathematical calculation, through segmented image, the final decision is coming by the artificial intelligence after the 5-6 different components which are inside of the reference value. So as you see the system, as I said, it can be also basic with the regular laboratory, with the regular invert microscope, with the basic softwares, which will be able to help for the embryologist to avoid for the wrong selection, for the sperm, for the oocyte, and for the embryo. So basically, it can use also in the regular laminar flow cabinet, not just on the X microscope. So you can use during the denudation, you can avoid different kind of morphological detect as well. So as video demonstration, so those are the number of the oocyte, different number of oocyte. Just you are leaving them under the microscope as an image or video, doesn't matter. And system is processing in a very short time, actually 10 to 15 seconds. And after this processing, we are getting that which oocyte we may select for the egg banking. So we can get the score of the oocyte and detailed mathematical calculation for each component which we want to evaluate it. Of course, again, we have to understand artificial intelligence is a machine learning. So we have to develop, we have to teach more, and we need to get more information by the artificial intelligence. As same thing for the sperm selection. So when we use for the sperm selection, of course, there are also on the sperm different component, different part of morphological part, which we are trying to analyze as the head acrosome, which is carrying up the DNA. So the tail and the cytoplasmic part, neck of the sperm. So we are selecting several sperm as an embryologist experience, which we are thinking morphologically they are looking fine. In another droplet, just we are giving them to system. So system is analyzing which of them we are able to select for fertilization. And then we are just selecting those one and we are using for the fertilization process. So of course, for the most of the cases as a normozoospermia, which we are considering, they have a normal morphology. So maybe you may think it will not be very helpful, but actually on the many teratozoospermia, the situation when we get the teratozoospermia, so system is really helpful for the selection of the best oocyte and outcome definitely increasing. When we do the oocyte selection by artificial intelligence, from one side, we have to consider quality, another side is quantity. So as an egg bank, we change our strategy. So we are not focused on now the quantity, we are focused on the quality, because that our experience show between the embryologists and artificial intelligence, still there are differences for the selection of the oocyte. From the commercial base, of course, for many of the egg bank, this is a minus because we are still losing 10% of the oocyte between selection of embryologist and artificial intelligence. But from another side, that's many good result, good outcome for the blastocyst rate and implantation rate is coming, which is the advantage. So as a graphic, also we can see the artificial intelligence selected donor eggs between the different embryologists. If we compare, also now amount of the euploid embryo rate is much higher than that embryologist base selected of donor eggs. As an advantage of the artificial intelligence, of course, biometric calculation may create a statistical algorithm for us for each individual cycle, which is very important. We can keep the record of the video data for the vitrification process, which we have the problem for features, so we can just back and to check where we made where we have the problem and we can detect and we can avoid this donor from the donor catalog, or to train embryologists more to release that problem. And of course that we can always get different information from the different sources by the artificial intelligence. Of course, till now I talk about artificial intelligence by oocyte selection, but still prior oocyte selection, there is still stimulation, and after that still there are embryo creation and quality of embryo. So this is a complex process. So artificial intelligence still can be included even for the stimulation for the optimal trigger timing. So we are giving just the starting day of the stimulation, and we are just giving the dosage of the hormones and the first follicle measurement. And artificial intelligence just can predict which day we have to give the trigger. So this is also an advantage, because we can find out exactly the high amount of the mature oocyte with the number of the size of the follicles, which we can determine much better as statistically. As you see, the day of the stimulation as a number of the total cycle, amount of the total cycle, which we give to artificial intelligence, and artificial intelligence already recommended trigger time, and we know the predicted maturation rate for the oocytes. As which I was talking, how artificial intelligence detecting different defect on the oocytes. Of course, this is the connected mostly which reference value we give the system, because the mathematical calculation after the artificial intelligence base, it should be compared with some of the reference values. So which reference values we are getting, which recommended by HRA, by SRM, different guidelines. So then artificial intelligence comparing this data with these guidelines and reference values. So this is how also detecting the spindle, and as I was talking about zona birefringes, as artificial intelligence selected embryos also can be the comparable with the genetic determination, because which is selected by artificial intelligence and with the PGT-A testing, as we saw the result, we find out the matching amount of the euploid rate is really closer. So this is the comparison of the euploid embryos by the artificial intelligence and by the PGT-A selection. As you see, the accuracy is really high. So this is giving a hope which clinics are not able to make PGT-A for the different reason, for the regulation reason, or for the lab condition or different condition. So artificial intelligence can be part of this process as well. And embryo ranking, of course, the embryo ranking also crucial. Still, that many of the embryologists can detect, of course, which embryo is a better quality than another, but still, this is a cycle process. Sometimes we have 3 or 4 embryos which we are considering as AA quality, and the patient is coming and we have to select one of them. So when we select by embryologist base, of course, we don't have the critical measurement and exact mathematical algorithm. So we are choosing according our eyes, which we are considering better. But artificial intelligence can improve this process by the selection. As artificial intelligence, we can use for the sperm, for the oocyte, and for the embryos. What we can detect? We can detect morphological sperm selection, morphological oocyte selection, fertilization and nuclear ranking, cleavage development ranking, blastocyst quality ranking, the morphokinetics development ranking if we are using time-lapse incubator. So best embryo ranking for the transfer to increase implantation rate, and embryo ranking, of course, for the cryopreservation. Another important thing for the artificial intelligence, of course, we know that our main reality to avoid human error. So traceability is much more important for many of us, for the patient as well. So we want to know that there is no risk to mix up of the material, even this is for donor eggs, the donor sperm, or patient own material. So how we can avoid this risk? Also artificial intelligence taking place here. So which we are implementing to our system as a fingerprint and face matching of the identification. So when patient come or donor come to reception, we are getting face matching and the fingerprint, and system is allowing to us for each process from the reception till the cryopreservation or embryo transfer. So all process is going under artificial intelligence and electronic witnessing process. So there are different possibility for the patient, as they can use RFID chip through the wristband, plus the fingerprint and the face matching. So that means 3 times we are witnessing the same donor or patient. So we are avoiding risk of mixed up. Even that is for the blood testing. So the same situation is happening. So the risk of to take the wrong blood for different donors or patient can be avoid those risks by the artificial intelligence. So donor or patient is coming to blood room, they are either making face matching or the fingerprint, and after that the label of the blood tubes is coming automatically from the printer. So there is no any human joining in this process. So all is going automatically. What human is doing, only taking blood. So the same things for the during egg pickup. So there are when donor or patient enter the operation room, they either make face matching, fingerprint, or wristband reading through RFID. So the all information is coming to main screen. Then patient and donor just approve that this is their information, and all information going to embryologist while they have the same screen on their workstation, and then the process is going. Each process in embryology lab till the oocyte embryo cryopreservation or till the embryo transfer is going by the RFID chip. So each workstation has these tablets or screens. When you come to next process as a denudation or fertilization or cryopreservation, the first you should read the RFID chip, and then system should allow you to pass the next process. If you take the wrong dish or wrong patient, so of course system will alert you. And another advantage, of course, as a lab director, wherever you are, so you can control all this system through your mobile application if there is some error or some mistake. Same things as a storage. While if you are a big center or egg bank, you have many eggs, many embryos, which you can control. Also tank control system, you can take the straw and you can release this straw automatically from your storage, and next time will not be a risk of mixed up as well. Well, if you do all of this, of course, that's also kind of improving your results, as this is a multi-center of the studies, so which is including more than 40 IVF centers from the different countries, different experience of embryologists, which we are talking about 13,300 donor eggs, which we receive 92.55% of the survival rate, 93% of the fertilization rate. If we checked day 5 and day 6 blastocyst rate, together is a really high number of blastocysts. And if we check the euploid rate, is almost 80% of the euploid rate. So artificial intelligence definitely improving. Of course, this is a machine learning system. We have to teach more and we have to get more benefits. Thank you very much for your time and attention.
Thank you very much, Birol. That was great. And we look forward for receiving the practical experience and your knowledge regarding the machine learning, Juan. So that's your time now.
Perfect. Thank you very much. First of all, I would like to thank you for the invitation. In the meantime, while I set up this presentation. Okay, there you go. So I'm very glad also Birol already talked about artificial intelligence. My objective in this talk is going to be a little bit different. It's going to be on how, it's a very introductory talk, so it's going to be on how we have applied machine learning methods in order to predict pregnancy in our clinic. So basically, I'm going to start by telling you that the Eugin group, basically the Elgin Clinic, started in 1998. And around 2014, it started its international expansion. Nowadays, it has around 20 partners in 12 different countries and with 69 clinics around the world. So you can imagine that this is a lot of information that we gather and a lot of data that we produce. And basically, we produce data from basic research from our embryology laboratory and also from our clinicians. And it was very natural to think, how can we integrate all this data together? So this is when we started exploring artificial intelligence, since this method combines computer science and robust data sets to predict accurately and ways to solve problems. And you may think, what's the main problem that we want to solve in our clinic? Well, the main problem that we want to solve by using artificial intelligence is to get our patients with a pregnancy after their IVF treatment. So putting together basic research data, embryology lab data, and clinical data, we can try to predict when our patients come, how likely they are to get pregnant. So today's talk, I'm going to divide it into 3 parts. First, I would like to define artificial intelligence and machine learning, although Birol already explained many things very well. I would like to make sure we understand where we are in terms of definitions. Then I'm going to explain how a machine learning method classifies its instances or its patients or its examples. And at the end, I'm going to explain to you Expect More, which is a tool that we have developed to predict IVF pregnancy. So let's start by the definition of artificial intelligence and machine learning. So as you heard from Birol's talk, we have these buzzwords that always appear in this AI field: artificial intelligence, machine learning, and deep learning. But sometimes they are used interchangeably. So my objective is also to try to put a framework on and know which methods are which and how we can use them in order to take decisions. So I'm going to explain to you all these 3. We're going to start by artificial intelligence. It's not going to be easy to explain what artificial intelligence is if we don't understand what actually intelligence is. This is not an easy task, but we can say that intelligence may be defined as an ability to learn and perform suitable tasks to solve problems and achieve goals in the context of an uncertain, ever-changing world. This means we're collecting tools in order that we learn in order to solve problems that we can solve in the moment or foresee in the near future, or we can or problems that we can avoid using these tools. And so we can also make predictions on how that problem is going to impact us and how we're going to approach it. So artificial intelligence then is the field that is going to attempt to use computer science to perform tasks by computers or robots that require human intelligence. So they will learn, solve problems, and achieve goals. And by doing that, they can approach problems such as visual perception, speech recognition, language translation, and decision-making. I have to say that artificial intelligence is an ongoing project. We're not there yet to get robots and computers to take the most important decisions for us. But there's a big leap that the field has taken, especially by using methods such as machine learning. So now we're going to move into machine learning. Machine learning is a subset of artificial intelligence. So not all machine learning is artificial intelligence, but all the machine learning methods are part of artificial intelligence. And these are a subset of algorithms and statistical models that are going to help the machine to learn and draw inferences from data in order to become more accurate at making these predictions. So I'm going to explain a little bit how does a machine learn. Basically, we're going to cover very quickly two ways that a machine uses to learn. It's going to use supervised learning. So you can see it here on the left. Supervised learning is a method in which we use labeled data. So your data is labeled, let's say here in green and red. And then it takes a decision on which ones are which ones. And unsupervised learning is another method in which you get your data that doesn't have any labels, and the statistical or mathematical model is going to try to find patterns in these labels and tell you whether there is any context in these patterns. Okay, so not all artificial intelligence is machine learning, but all machine learning methods are artificial intelligence. Now we're going to go into deep learning. Deep learning, as you can see it here in the figure, it's a subset of machine learning. So it's basically a machine learning approach that uses something called multi-layer neural networks. And these are networks that are inspired on the way biological neurons signal to each other. Just as Birol explained to you, artificial networks have this structure here in which you have inputs of variables that are going to feed into hidden layers and hidden units of the algorithm. And these hidden units are going to transform the inputs or the variables that they receive in order to get an output. This is a very complicated process. It's mathematically very intense, also statistically and computationally is very intense. And this is why these artificial neural networks or deep learning networks methods, are typically the most accurate machine learning methods and are ideal to process complex data like videos of images, just like Birol explained to you, on real time even. And this is why these deep learning methods have helped machine learning to reach its goal of arriving to artificial intelligence. However, being so complex comes with a cost. And specifically, this cost is that since, as I told you, we have an input variable that goes into a hidden layer, it transforms these variables to produce an output. We cannot really, once we have an output or a prediction, we cannot really go back and see what happened to this variable to make this prediction or this output. So we say here that our model loses interpretability. This is very important when we use clinical data because we want to know exactly when we make a prediction for our patients where these predictions are coming from. We need to interpret what these variables that, are doing in order to tell us how good the prediction for each patient is. Okay, so for clinical data, we're going to focus on machine learning methods. We're going to leave out deep learning at the moment. As I told you, it's a very good method to analyze images, videos on real time. But we're going to focus specifically on machine learning methods that are not deep learning. And it's going to be very important that these methods learn from the data that you provide, and that they make accurate predictions. So now we can. So I hope these definitions of artificial intelligence and machine learning were easy to follow. Now what I'm going to explain is how classification works in when we use machine learning. So, as I told you before, we're going to use supervised learning methods in which we have labeled data. So our machine learning algorithms are going to learn from this data, and then they're going to make accurate predictions. So my objective in this part of the talk is just to explain to you how this classification takes place. So basically, let's say we have a problem that we need to solve, and we need to make a prediction in order to solve properly this problem. Let's imagine we have a couple of friends that came to ask to make a machine learning algorithm because they really need to know. We're going to keep their names anonymous, but they really need to know they have a very, very large garden. And from that garden, they have many, many fruits. And they need to know which ones of those fruits in their garden are apples and the others that are not apples. So they need to classify their fruits. It's very important for them and apparently also for their lifespan. So this task of classifying apples and not apples can be very easy if you compare apples, for example, here to other fruits like berries, grapes. But it might become a little bit more difficult when you compare them to peaches, for example, because you see apples and peaches look more or less similar. And not only that, the classification might become a little bit more complicated whenever there's variation among the apples that we're going to classify. So there are smaller apples that could get confused with other fruits, and larger apples that could get confused with peaches. So of course we know how we have learned already to recognize these fruits, but we need to teach this and allow an algorithm to learn what are the characteristics that is going to help this algorithm to classify these fruits. So how can we do that? Like, first thing that we need to do is to get variables from these apples or from all these fruits that we can quantify and measure. So we can get the height of the apple, the width, and the color score. And we can put them into a data set here. As you can see, we have in the columns, we have the different variables: mass, width, height, color, the sweetness, a score of sweetness, the season where we can harvest this fruit, and the name of the fruit and the label. I'm going to explain this in a little bit. So each of these rows here are each of these is an example of the fruits with its specific mass, the width, the height, the color, and we have the name of each fruit. And we're going to have a label that is telling us whether this is an apple or it is not an apple. So that's the thing we're interested in classifying from all these fruits that we find in this garden, which ones are apples and which ones are not. For us, it might not be very easy to classify or to observe all these variables into a graph, because if we were to plot all these single variables, let's say in one axis we will get the mass of the fruit, in another axis we will get the width, here the height. Let's say we put the color score here, but we're still missing the sweetness or the season in which it is harvested. So for us, it's very difficult to try to plot all these variables, but for machine learning methods, it's actually very, very, very easy, because machine learning methods are methods to treat multidimensional data. So what I'm trying to say here is that each variable in this data set is a dimension when we try to express it into a plot. And we have the labels of these of all these variables here and all these examples. Anyway, for purpose of explanation, we're not going to think in multidimensional data, but we're just going to take two variables, right? Let's say width and height, or color and mass, whatever, it doesn't really matter. We're going to take this data set and we're going to call it the training data set, because we have a label. This is a supervised machine learning method. We have a label, we have a data training set, and we know that our blue dots here are apples and the yellow ones are not apples. And what we're gonna do is we're gonna apply a statistical method called a classifier that is going to help us classify these fruits. So basically it's going to take all the variables in all the dimensions, so here we're just seeing it in 2 dimensions, and tell us, okay, I'm gonna draw a spacer here, and everything that you find on the left of this divider is going to be in the apple space. So everything that you find here, I'm going to classify it as an apple. And everything that is on the right is going to be in the not apple space. So everything that you find there is going to be classified as a not apple, right? Then we're going to use something called the test dataset, in which we're going to use different instances or fruits with their different measurements, but without the labels. We're just going to tell the algorithm, okay, now we have all this data. Let's see how well you do in order to classify them. And based on the mass, width, height, color, and sweetness, the classifier is going to put them in a specific part of the space, whether and it's going to say whether this is not an apple or whether this is an apple. And since we have the labels for this, we're going to be able to tell how well the classification was performed. So basically, this is what a classification or a machine learning method is doing to classify the data. And we can tell how well it is doing it based on how good the classifier is. You can see here that in the not apple space, there are many individuals or fruits that are actually apples, but are being classified as not an apple. And on the other side, there are very few that are not apples, but are being classified as apples. So basically, we can use this in order to evaluate how well our machine learning method is doing. And these are called performance metrics. By using, for example, true positive individuals, so that means the ones that are apples and were put into the apple space, or true negative individuals, which are the ones that are not apples and are put in the not apple space. And also classifying the ones that are false positives, which are not apples, put in the apple space, and false negatives, which are apples, but put in the not apple space. So all this just to say that by doing calculations with these true negatives and positives, we can get the accuracy of the method, and we can tell how close is a measurement to its true value. So the accuracy is going to tell us how well this classification is being performed. And also we're going to be able to use something called the receiver operating curve, area under the curve, to measure the ability of a classifier to distinguish between classes. So in this case, the area under the curve in a classifier, if we have a number that is around 0.5, this is no better than a random classifier. And as this number increases up to 1, our classification, or the ability of this classifier to predict between classes, is going to get better and better and better. Okay, so as a summary on what machine learning methods are doing for classification, we have supervised learning with labeled data, in which we provide a training data set to divide our data set into two spaces. The feature space, where we have a positive class and a negative class, apple or not an apple. We applied a statistical method called the classifier, who's going to make this division. And then we're going to use a test set to see how good or how well this classifier is doing. And by using the accuracy of these predictions, and the area under the curve of the classifier, we can tell how well this model is performing. So basically, now we can predict and know how well we're doing, and deciding whether the fruits that we're giving to the model are apples or not apples. So in this way, we're solving a problem for the couple that came to ask for classification of the fruits. So pretty much this is exactly the same method that we use, but in clinical data. And we're not going to be using it for fruits, but we're going to be using it for patients. So what I'm going to explain now is how our algorithm expect more that we have developed in Eugin has helped us to predict IVF pregnancy success in our patients. So pretty much the way we predict pregnancies before machine learning is using generalized age-based data. And what this means is that we use the mean success rate of an IVF clinic, so how good the IVF clinic is, the patient age, and clinical experience, in order to tell all the patients in our clinic that are less than 35 years old what's the probability of having a pregnancy in the first transfer or in accumulative transfers. And this is going to be changing depending on the age of the patient. But as you can see here, this is not a personalized prediction. This is just a general way to tell a patient, well, you know, your probability about getting pregnant is going to be around 48% in the first transfer if you are around between 35 and 37 years. But, you know, we do not exactly know what's your specific probability, but most of the women or most of the couples in your age range are giving us that prediction. But if you use a machine learning model, we can improve this prediction and we can make it personalized. How can we do that? What's the process of developing a machine learning model in an IVF clinic? Well, first we can collect data using electronic medical records, in which we can get genetic data, patient characteristics, treatment history, different concentration of hormones, whatever we can get from these electronic medical records. And we will have to pre-process this data. This is one of the most important steps in developing a machine learning model in an IVF clinic. And specifically because you will see that a lot of the data that you have is going to be or either empty or with wrong units. So most of the time that you spend in developing a machine learning model is going to be in the pre-processing of the data and preparing it properly for the machine learning method. Once we have pre-processed our data, we're going to select a machine learning model. There are different models that you can select depending on what they do statistically and mathematically. And once we do that, we will be able to train the model, evaluate it, validate it, and apply it to solve a specific problem. Okay. So this is exactly what we have done in Eugin through the development of Expect More. We used IVF cycles from January 2011 to December 2018 from our clinics in Spain, Italy, and Colombia. And we used patients that got their first IVF cycle and had a maternal age up to 43 years. And one of the inclusion criteria was also that they use autologous oocytes. Of course, the exclusion criteria was the use of donor oocytes. We wanted to predict the probability of these couples getting pregnant with their own oocytes. And also we excluded the couples that used pre-implantation genetic testing to see the haploidy of their embryos. And the success of the first IVF cycle was identified as a positive pregnancy test after embryo transfer. So looking at our data set, we got around 8,000 cycles, you can see here, that satisfied the selection criteria. 77 of these patients were from Europe, 14% from Africa, 6% from the Americans, and 30% from Asia. And from these European patients, 45% were from France, 32 from Spain, and 22 from Italy. And from the African patients, you can see here that 50% were from Northern Africa. What this means is that we have a very diverse and heterogeneous population that represents very well the Mediterranean population of the world. So if we get all this data, we can classify it, we can look at all the characteristics, all the variables that we can collect, like maternal age, paternal age, BMI, FSH concentration in the blood, AMH, antral follicle count, sperm concentration, progressive motility, gravidity, parity, previous miscarriages, and the use of donor sperm in the total of the population. And we can see how many of them got pregnant and how many did not get pregnant. So in this case, similar to the fruit example that I gave you, we have the specific variables that we use, and we have the labels of the data set, pregnant or not pregnant. So we applied then an algorithm known as the gradient boosting classifier. This is very similar to a random forest in which decisions are taken that builds on upon the previous tree that is being made. We used 80% of our data set to train the algorithm and 20% to test it. and see how well it is doing. And then we calculate the cumulative probabilities of the first, second, and third embryo transfers. And we see which ones of these patients got pregnant and which ones didn't get pregnant. We perform an evaluation by using a cross-validation method. This means that we repeat this process of prediction 10 times, giving us a very robust prediction on what we're doing. And our main result is that we have an accuracy of 67%, which we can compare with the age-based estimate. So before we were doing okay at predicting pregnancy when we were telling the patients how well or what was the probability based on the age and the clinical experience. But now we increase at least 6% by using a more personalized algorithm. And the area under the curve, which tells us how good this classifier is, also increases, as you can see here. The main advantage of using this algorithm, Expect More, is that we can collect the data from the patient. So let's say we get the female data, we get their age, body mass index, anti-Mullerian hormone, antral follicle counts, and also the etiology of the patient. This doesn't take much time. It can be incorporated into the clinical practice easily to the medical doctors. We can also consider the toxic habits of the female. We can do the same for them to capture the male data, age, sperm volume, concentration, and motility, also their etiology and toxic habits. And once we get this data, we can ask the model to make the prediction. So we can have a prediction of what's the probability of getting pregnant at the first transfer. Let's say we apply this algorithm to a specific patient that tells us that your probability to get pregnant at the first transfer is 41%, then 46% in a second transfer, or an accumulated probability of 52% after your whole cycle. Not only we're going to tell the patients what is their specific probability, but now we can compare their probability, let's say the cumulative one that we can see here in dark blue, to a light blue probability that is based on the overall population of the people their age, or the female their age, or couple their age. And we're going to tell them how well they are doing, or whether they can do something in order to improve those chances. Because as I told you before, the use of machine learning methods and the advantage of them is that they are interpretable. So we can tell them what are the specific features or variables, like for example, maternal lifestyle, that are downgrading the probability or putting it down, and which are the favorable factors or the favorable variables that are increasing their probability. So the Expect More algorithm is not only helping us to predict the pregnancy of each patient, but it's helping us also to counsel them on whether there are any variables that can help them improve their probabilities. So the strengths of the Expect More algorithm is that it is producing a large and diverse data set. It can measure the impact of multiple variables on cycle outcome. It does not take too much time from clinical practice, and it supports clinical counseling. And this is specifically very important because it might encourage poor prognosis patients to adopt a more favorable treatment option. Let's say in the case of a specific couple, the sperm parameters are very low. Maybe you could try to improve your probability of getting pregnant by using donor sperm. And we could calculate the probability with using the own sperm cells or also from a donor. The limitations of this algorithm is that it is used in first cycle patients, because since we want to predict the probability of only patients in the first cycle, then we can only use it in this type of patients. And it is limited only to IVF patients. Of course, our database is just of IVF patients. We cannot use these methods to predict pregnancy in the general population. And so we have been working on this with Eugin on developing Expect More, and we have also some objectives for the future. We're currently working on incorporating predictions for intrauterine insemination and oocyte donation. And this is going to allow comparison among different treatment strategies for patients to giving even better counseling strategy for them. And later on, we're also planning to incorporate predictions for PGT cycles in order to be able to predict even better which embryos are going to be euploid and which ones are going to give pregnancies and with a very high accuracy. So this is a model that we have developed, expect more, to predict pregnancy success in the first IVF treatments. And basically, nowadays, our patients in Spain, Italy, and Argentina, and also we're expanding it to other clinics, now are using it, and they can receive a personalized pregnancy prediction that is based on an intelligent algorithm that help us classify our huge data set and make an accurate prediction of their pregnancy chances. And with this, I would like to thank you for your attention, but I would also like to thank Mina Popovic, our scientific director. She started very recently in Eugin as a scientific director, and she has kept open door policy for us in doing science. So thank you to her for allowing us to perform our duties. And this is the whole data team in the Eugin group. We're all working together to develop and improve our prediction models. Thank you very much.
Thank you so much, Juan. It was really interesting and very clearly explained. As for the doctors, I believe also for individual patients. And that's very right that in order, myself as an IVF specialist, while doing the consultation for the patient, one of the main questions is, what can we predict? What can we expect? Yes, they are asking, what would you doctor do differently? That's also very important because most of our patients who are reaching us for different treatment techniques, they are with many IVF trials before, they are international patients, they have different experience as well, and we need to consider everything. I have a question regarding more just a practical or technical one. While you showed the predictive outcomes for different age range of the patients, you've been comparing the first cycle outcome and the cumulative. How many treatments, how many transfers you considered in the cumulative? Because the difference in between initial embryo transfer and cumulative was not much different. Then was 1% for over 43, several percent for over 40, and even for young age for less than 35, that was as maximum 70 something. So what was the cumulative? Still limited or non-limited?
So no, the cumulative, it's basically 3 or more. Basically, in our practice, most of the cycles or patients either get pregnant or not after the third transfer.
Okay, so non-limited cumulative.
Exactly.
Okay. Yeah.
So after that, we have very few cycles that go for 4th, 5th, 6th transfers. Given the amount of data we have. Like, for example, from this 8,000, probably less than 5% go for more than 3 or 4 transfers. Yes.
Yeah, understandable. And regarding really the data is huge, and the geography, the ethnicity diversity was really interesting. Have you seen differences in the clinical outcomes based on the ethnical diversity of the patients?
Yeah, well, you know, we at the beginning we were trying to look at the ethnical diversity of the patients, and this is why I also underlined during the talk that data pre-processing is very important, because we do have the nationality of the patients. We didn't look further into ethnicity because the nationality doesn't tell us
Doesn't
what
match. I
ethnicity
see.
exactly.
Yeah, I see.
So we had a lot of, or we have the nationality of all our patients, but nowadays ethnicity is so difficult to define, right?
Right. Yes, I see. So I didn't recognize, like, yeah, fine.
Yes, you can have a patient from the Netherlands, but the mother was from the Caribbean and the father is from Italy. But it's becoming a very it is very important to look at ethnicity. It's just that nowadays, with such genetic diversity, it's becoming more difficult to trace it. Yeah.
Yeah, right. In our practical experience, because as Ovogene, we are recruiting donors in the different countries, and mostly this is a pure population because it's a local population. For example, local population in the Eastern Europe or local population in Asia, etc. And we do see the differences, not the differences in terms of the clinical or embryological performances, like the follicular oocyte index, for example, or maturation rate or blastulation rate, etc. However, for example, antral follicle count or IMH level, or the most different is the number of the retrieved oocytes, so the reserve in the population in Eastern Europe, for example, really different from Asia. So it's more oocytes we are collecting from the European donors than the Asian donors. And this is
one of the things too. Yeah, this is one of the things maybe we can touch upon in this discussion. It is important, I think, for me to emphasize that whenever a clinic develops an algorithm, that algorithm is going to be used for that clinic's population. And it is because the population from your clinic is going to be biased towards a specific, like you said, more Eastern European, more Asian. Ours is more biased towards Mediterranean population. So it would be very difficult to try to take it to other populations. Now, the advantage of the Eugin group is that now we have also partners, for example, in Nordic clinics, in which we can get data from them, in which, for example, in Copenhagen Fertility Center or in Stockholm, we can try to analyze their data and see how well the model adapts to that type of more homogeneous population. But yes, when you have a model, it is developed on a specific population of patients, then it's very difficult to translate it into a different population. Maybe this is why the reason why sometimes clinics try to use algorithms from different that were developed elsewhere, and most of them say, well, it doesn't really work for us, but it's because the populations, exactly, the populations are different, but the method is always the same.
Yeah, right. Birol, do you have any comments, questions?
Yeah, actually, for me also, that the question regarding ethnicity, like I'm really wondering that how it can be not just for the egg donors is more easy and predictable. So to find out, while the many countries, the legislation is asking the donor can be without child, so most of them are not married, so they are young donor, and to follow ethnicity more easy. But for the IVF cycles, it's really I mean, I know it's difficult to track that, to find out that, but still I'm really expecting from some group, research group, to find out information. It should be very interesting, actually.
Yeah, no, I think the recent development of most of the genetic techniques is going to lead us to define ethnicity more at the genetic level rather than at the phenotypic level, right? And I think that's going to help in the future. Also, we have a very good oocyte donation program, and that's right. We have a very homogeneous oocyte donor population. Actually, when we wanted to try to see whether we can classify our population, we found that it's very homogeneous, of course, because they are all young, around the same age. They have a very good ovarian reserve. They have they have to be in a normal weight, so BMI has to be below 25. So there are very, very few variables that we can just control that could tell us or help us classify these donors. At the end of the day, we found it was on mainly the parity of the donor, like whether they had previously had children, in their age, when they reach around 30, 33 years. Those are the donors that provide eggs that can result in more pregnancies. Yes.
Actually, artificial intelligence is a good point to detect that.
Exactly.
Because
exactly.
different variants. So artificial intelligence, basically, we established to collect more data, more different data, and to mix up this data and to create a one data which we want. So here that ethnicity from the father side, the mother side, and from the family members to collect all this genetic component by artificial intelligence could be really interesting.
Yeah, definitely. I think one of the my main objective, I hope it was transferred to you guys, is that sometimes when we talk between embryologists, clinicians, engineers, computer scientists, there's this mismatch on information. Sometimes
Right.
it seems like the models are so difficult, impossible. It's mathematics. I don't want to know anything about it. Just tell me whether it's gonna get pregnant or not. But if we learn to understand each other, I think that's when more synergies can be made. We can take better decisions. We can ask for specific variables. Like the computer scientist can come and tell you, well, these are the features or the variables that you can use. But if you understand them, you can say like, well, actually, from all these lists, I would also only like to know this part, and I want you also to include this and that, because then it's going to improve the models. I think it's important that we understand each other. It's going to be much better for the field. Yeah.
Yeah, I have one more very specific question regarding the artificial intelligence. That's probably the most commonly asked one right now, because how people are reacting into something new, different. And there are some professionals who are not admitting, like we all understand all the benefits connected with the artificial intelligence, and we are using this truly as a benefit and as an option to improve and learn and optimize the outcomes. However, what do you guys think regarding what's the future of the artificial intelligence, specifically in IVF, and how much that will impact our daily routine, our practical involvement, and what will be the role of the individuals like doctors, like saying other words, are we not going to lose our jobs? Like, I'm not on that part, absolutely. That's just the question commonly asked. So let's talk a little bit about that.
Yeah, do you want to go, Birol, or do you want me to go for?
As you wish, you can.
Okay, I think artificial intelligence is going to be a great tool. As I said, a lot of people, even in general population, most of people now is scared of how far ChatGPT is going to reach, and whether artificial intelligence is going to turn around and maybe start killing humans. No, all these catastrophic futures, but I think as long as we understand the technologies, we're going to be able to understand that it's going to be difficult for them to reach a point in which they're going to damage us, specifically for some reasons. I think we're not even 10% into that path. I don't think we're not even close to 10% on a robot getting a weapon, starting killing us, because we cannot even get the self-driving cars to properly park in some spots. So, you know, sometimes they make mistakes. Face recognition it's very good. The methods are growing, but we're not there yet in order to recognize everyone from a whole population or in a whole city. You know, people are working on that, but we're not there yet. And specifically, I think we need to get into conversations with philosophers. I have a very good friend who is a philosopher, and he has explained to me what defines humans as entities. And we are defined as entities, as biological entities, because we know that we want something. We have an objective, and we have this intrinsic need to reach a specific goal. And we can see it in our field on the couples that have this objective or this need to reproduce, to leave progeny, right? And artificial intelligence is not going to be able to have this intrinsic necessity of achieving a specific goal, because we need to give them what objectives they have to fulfill. So I don't know, it's a philosophical question. I think we're not going to reach that point in which they're going to turn and kill us. I think we're going to have to learn to use it as a tool. It's going to be a powerful tool. You know, their ability to look at so many dimensions, you know, how many variables you have in a data set, hundreds. Well, the machine learning method can see in 100 dimensions. We can only see it in 3 or 4 maximum. The computer can do it in 100 dimensions. And once we learn to do it, yes, we will have to prepare ourselves to interpret these models. But, you know, it's going to be a process. But, you know, I imagine, like Birol explained, you know, you're with your phone at home, you're receiving information, the artificial intelligence model is telling you, okay, these are the parameters that I got from the eggs, from the embryos, and you take decisions. Automation and decision making is what machine learning is going to offer for us.
I will tell about these common words. So it's just, you will not lose your job to artificial intelligence, but you can lose your job to someone who is using artificial intelligence. So you have to use artificial intelligence from that perspective. For me, that is not a point for the selection. What I'm waiting from artificial intelligence, because still risk of errors in IVF labs for the clinical part is high. So the artificial intelligence will enter to the IVF field and will decrease this risk. So I'm looking at the artificial intelligence, the most adequate as most quality of the quality management software, and to avoid all possible risk, because we are human and we are so open to make errors and mistakes. It can be different kind of, it's not just that means we can mix up the embryos or something, but still to choose wrong embryo, to lose some information, because there are many information for each patient from different base. While doctors, IVF specialists making consultation with patient, and patient is saying that there are different information, which some of them as on the software you can follow, but some of them between talk you can miss, which is very important for embryologists. Maybe we can consider to change culture protocol, we can consider to change the way of working. So all of those things in every clinic I'm talking, for every experience, we are missing. So the artificial intelligence is point here to collect this data and to show to us, to don't miss, and to give us a more option to use a different technologies, different lab techniques to improve the process. So this is the point of artificial intelligence. Of course, that after artificial intelligence, to accept that everyone will get pregnant, that every embryos will be implanted, it's not right, because still there are multi-factors which we cannot avoid. There are genetic factors, there are epigenetic factors, the metabolic factors, immunological factors. So the artificial intelligence is not solution of the main solution of the life. So is the solution for us to give us that right atmosphere and the probability which we can choose the best way for each patient. So this is the point of artificial intelligence in IVF, as for me.
Yeah, I think
great.
I agree with you.
Yeah,
You
we
know,
all agree on the
yeah.
fact that this is a tool, this is the instrument, really new and unique, which we need to first educate, because just a human would understand what is needed from this instrument and how this may help to optimize, to bring more efficiency, etc., etc. And then we should make it a friend and a partner for our routine daily work. Right.
Yes, I just want to add one more thing is, of course, we're going to rely on artificial intelligence, automation, robotics, and all that. But, you always have to consider as an embryologist or as a clinician, what do you do if in your practice, everything is being done by artificial intelligence and robots, and suddenly one of it breaks? Someone has to be there with the knowledge to either fix the robot or start doing the ICSIs at that specific moment, So as embryologists and clinicians, we will have to be trained in knowing artificial intelligence and somehow keep our old methods in case these novel methods don't work anymore. So I don't think we're going to lose our job. It's going to be just a tool to help. Yeah.
Yeah.
If we saw risk, just we will broke them.
Yeah. Great. Okay, fine. I really appreciate your time, guys. And that was really interesting for me. I believe for everyone who has joined us. And we have this meeting recorded, and we will be able to share with all teams and all who have been registered and to watch it later. Thank you, Juan, for really great presentation and for constructive discussions and for the friendly one. Really appreciate this. And thanks for Eugin Group for sharing also their experience and allowing you to join and just partnering on this webinar. We look forward for more activities together and the cooperations.
Thank you for the invitation. It was great also to know what Birol presented and to get to do things together. Thank you.
Right. So thank you everyone for your time once again, and we keep checking all our activities. Soon we will be preparing the next webinar session from Ovogene. Thank you that much and see you soon. Bye.